Good morning, good afternoon, or good evening, and welcome to the next episode of Numbers with Nando. Today we are looking at everything to do with fitting circles to 2 points. I'm just going to use a convenient example where the circle fits really nicely. So we've got these 2 points here, 3, 2, and 7, 6, and we want to fit a nice curve to these points. Now, as I said, these points are quite convenient. If we look here, we're 4 units from that point, and we're 4 units from that point. So we can just put our center here. It's got an x coordinate of 7 and a y coordinate of 2, and the circle will have a radius of 4. A radius of 4. So that's actually everything we need to know to make our equation. It's just going to be x minus 7 squared plus y minus 2 squared equals the radius squared, so equals 16. I'm going to go pop that into Desmos, and then we're going to talk about how to reflect it all over the place. Okay, that screen was meant to move with it. That's all right. Let me just set this up a bit better. Put that to the right. Cool, now they're moving together. Okay, so as we said, the equation was x minus 7 squared plus y minus 2 squared equals 16. Okay, and we've got this lovely circle. Now we just wanted this positive quadrant of the arc. So I'll do the domain first. I always write less than equals x less than equals. I want x to be greater than 3 and less than 7. Here I need to also put in my range. I only want y to be greater than 2. Y greater or equal to 2. Right, and that is done. Okay. Now we want to reflect this in the y-axis. That's the first thing we'll do. I'll make a little folder for this. Create a folder. Reflect in y-axis. So we want to flip it downwards. Now we can't use function notation because a circle isn't a function. Because values of x take more than one y value. That's why we've had to write it in this different form here. We can't write it y equals, in other words. Instead, what we're going to have to do to reflect in the y-axis, not flip it downwards, we're going to be flipping it sideways, crosswards across the y-axis. We want every value of x to go to negative x. So this actually still works. Because if we see an x, swap it. Okay, now this works, but this here is a little bit ugly, and it's not clear that someone who wrote that that would know what they meant. So let's see if we can simplify this a bit. We have got 3 is less than equal to minus x, which is less than equal to 7. How can we write this nicer? I'll just take the first part. The second part. Negative x is less than or equal to 7. I'm going to add x to both sides. Take away 7 from both sides. So I'm really saying x is greater or equal to negative 7. Same with the other part. I'll add x to both sides, take away 3 from both sides, and I get that. So really I've got that x is greater or equal to negative 7 and less than or equal to negative 3. So that looks a bit nicer. They both work. So I'm just going to copy this here. It still works, but this shows that you know what you're doing. X is greater than negative 7 and less than negative 3. So So we get the exact same thing. They're just landing on top of each other. All right, what about reflecting in the y-axis? So in the x-axis, so flipping it downwards. Same thing again. Every value of y, instead of being a positive value of y, I want it to be the equivalent negative value. So wherever I see y, I want it to be negative y. Wherever I see y, I want it to be negative y. And again, we can rearrange this domain. Actually, we'll add y to both sides. Take away 2 from both sides. Get y is less than or equal to negative. And I'll make that black as well. So these two are equivalent. But this shows that you know what you're doing. Okay. So far, so good. Finally, what I want to do is move the circle segment, let's say 5 units to the right. 5 units to the right. So I'll get my original 5 units to the right. So wherever I see x, I want to replace it with x minus 5. So I'll replace this x with x minus 5. Replace this x with x minus 5. And we can see that it works. But as you know, I'm going to rearrange this to show that we know what we're talking about. Minus 5 minus 7 is minus 12. Plus 5 to both sides of the equation, so 3 plus 5 is 8. Plus 5 is 12. Okay. While I'm at it, let's do a couple more things. We will move the circle segment. Why do we move it? 5 units. My original function. Five units upwards, so y minus 5, because I'm moving it up. Minus 5. Also, that has worked. But we will rearrange the equation. Minus 5 minus 2 is minus 7. Plus 5 to both sides. So 2 plus 5 is 7. Okay. And that is a bit nicer. I'll make both these orange. Okay. Final thing we're going to do is move it not just 5 units to the right, but arbitrarily far to the right. So move p units to the right. Let's just start from scratch. Get the original function. P units to the right. So if I see x, I want to swap it with x minus p. Minus p. Okay, we'll see if it works. Yes, it is working. But what am I going to do? Yes, you're right. This is as nice as it can go. Here. The domain should really be written in terms of x. So I'm going to add p to everything. 3 plus p plus p plus. Okay, and we can. P is getting smaller, so it's moving to the left. P is getting bigger, so it's moving to the right. Okay, and what I will leave for you to do for exercises, I'll post this Desmos file, but what I want you to do is reflect the circle in both axes at the same time. And why not? Yeah, just let's leave it at that. Let's see if you can reflect the circle in both axes at the same time. Go for it. Hope that was helpful, and we'll see you next time.